Good morning and welcome all of you to this series in the academic training. As usual, before I start the introduction, I would like to remind you how the lectures will work. So first, the speaker will deliver the lecture, followed by a question and answer slot at the end. However, Colin was very kind, and he was saying that even if he sees something in the chat that is for a short clarification, he will read it and then clarify at that moment in real time. But if not, then later, don't worry that I will review all the questions that you post in the chat. I will read them, or you can always raise your hand and at the end, and I will give you the turn. So also another sad notification that I have to give you before is that we will not have a lecture tomorrow, Thursday, due to personal reasons of the speaker. However, we will have our last lecture on Friday, okay, at the same time. So, okay, today I'm following with our outstanding speakers. I'm delighted to introduce you our third speaker, Colin Perkins, who is going to talk about defining network protocols standards. So we are going to learn a lot of things to him. But let me tell you some words about him, because he's an associate professor in the School of Computing Science at the University of Glasgow and the current chair of the Internet Research Task Force. He is involved in all these topics regarding network transport protocols, with a particular focus on protocols for real-time and interactive multimedia on the internet. Also, he was mentioning improving the design implementation of standard network protocols. Also, he's a long-time participant in IETF, where he helped develop technical standards for the multimedia transport and signaling protocol standards that underpin modern video conferencing platforms. Also, he is co-chair of IETF Real-Time Media Congestion Avoidance Techniques Working Group. And previously, also, he co-chaired the Audio Video Transport and Multi-Party Multimedia Session Control Working Groups. So, yeah, he is quite busy, I can see, in all these areas. And so I'm sure that we are going to enjoy a lot his lecture today. So please join me to welcome Colin Perkins. So now the floor is yours, Colin.
Okay, thank you. Can I just confirm that you can all hear me and see the slides, okay?
Yes, perfect.
Okay, all right. Just rearrange things so I can see my screen here. Okay, so as Maria said, thank you for the introduction. I'm Colin Perkins from the University of Glasgow. And what I would like to do today is talk a little about the process by which we define network protocol standards. And as Maria said earlier, I'm watching the chat, so if you have any questions for clarification or any quick questions as we go along, then please do jump in and ask them in the chat, or I can answer longer questions at the end. So yeah, what I want to talk about is defining network protocol standards. And in particular, I want to talk about two high-level topics. The first being what's the process for defining internet protocol standards? How does one go about designing these standards? How long does it take? How does the process work in general? And try and make it clear to you that this is a process which is feasible for someone who is not necessarily deeply embedded in the standards world, and that it is possible to change the way the internet standards work. And then in the second part of the talk, I want to move on and talk a little about what's happening in the research world and in the IETF, in the Internet Research Task Force, and things which are coming down the pipeline which might affect Internet standards and might affect the way the network operates in the longer term. So to start with, I want to begin by talking about the Internet standards process and why you might care about protocol standards and how are the Internet protocol standards developed. So to begin with, why might you care about Internet standards? Well, there are obviously a large number of organizations involved in developing and standardizing Internet protocols. The Web Consortium, as you know, originally grew out of something developed at CERN. The ITU is also, I think, nearby you in Geneva. But there are also many other organizations developing standards. The IETF, where I've spent a lot of my career working, the FreeGPP, who do mobile phone standards, MPEG, ETSI, and many, many others. And I guess the question is, as a researcher, as a scientist, as a network operator, why might you want to get involved in these standards communities? Why is it worth your time in engaging with these organizations? Well, there are of course a number of reasons. You may be altruistic. Maybe you want to make the network better. Right? Maybe you want to get involved in standards because you think you can improve the internet, you can improve the interoperability of the systems which comprise the internet. Maybe you're there for the common good. Maybe you're trying to make the network work better. And that's certainly a reason why many people get involved. Maybe you want to get involved because you might learn something. Maybe you want to get involved in order to better understand the process by which the standards are developed, the process by which the network operates. And certainly as a networking researcher, someone who does network protocol research for a living, this is one of the reasons I certainly am involved, in that every time I go to the IETF, every time I interact with the people designing standards, developing products, building products using those standards, operating the networks, I learn an awful lot about how the network really works. And I think I would, as a networking researcher, I think I would be missing something significant if I wasn't so closely involved with the standards community, with the protocol developers, with perhaps the network operators as well. So I think this is certainly a very good environment to learn about how the network works, learn from other operators, other protocol designers, and so on, and share expertise as well as developing standards. I think it's also important that as researchers and scientists and network operators, we are involved in the standards community to try to perhaps keep the industry honest. I think it's important that we don't just have large tech companies developing internet standards. It's important that we get a voice from academia, a voice from the science community, a voice from the network operations community, a voice perhaps from non-governmental organizations and other civil society groups in the standards community, to make sure that standards are being developed with regard for the wider community using the internet. And that the standards are being developed in a way that reflects the needs of everyone using the internet, even those who are perhaps using it for things other than traditional media consumption. And I think this is one area where the networking research community can play a strong part, but I think it's also an area where the broader science and operations communities can play a part. Because they have needs which are perhaps not mainstream, and because they push the edge of what the network is used for in a number of directions. I think this is very useful in order to help those needs be reflected, keep the industry honest in what they're developing. And of course, I think that the main reason you may want to be involved is because you want to improve the systems you use. Working with the protocol standards communities, I think, is a very good way to help make sure those standards reflect your needs, to help improve the systems you use, make sure that they address the broad range of needs of all of the users, especially those who are as I say, pushing the boundaries of what the network is used for. And as I hope I will show later, it's possible to actually have quite a big influence on the standards and the way the standards evolve as an academic, as a researcher, as an operator. So I think there is significant scope for changing the way the network works and making it better suit your needs by becoming involved. So obviously, there are lots of standards development organizations. I want to focus primarily on the IETF today. The IETF is one of the, if not the premier standards development organization for the internet. It grew out of the original research projects in the US that funded the Arpanet and the NSFnet and the original network protocol developments there. And these days it's a large community of protocol designers, operators, vendors, and researchers who volunteer their time to help guide the evolution and development of the internet architecture, define the protocols which form the internet. The mission of the IETF is very much to make the network work better by producing high quality technical standards, the RFC series of documents, which I'm sure many of you have heard of. And these documents are voluntary standards documents that describe the way the network operates and that influence the way people design, use, and manage the network. And as I say, its primary purpose is to develop these standards, but it also has a significant role in sharing operational expertise and sharing experience in the community. A parallel organization to the IETF, perhaps less well known, is the Internet Research Task Force. And the IRTF is there to promote the longer term development of the internet. It's there to provide a forum by which the networking research community and the internet standards community can come together and discuss and share expertise, and a way in which ideas from the research community can filter into the standards community, and equally a way for the standards community to interact with the research community and feed their needs and their problems back to the researchers. And they're very much a symbiotic relationship. The IETF develops relatively short-term standards, looking maybe 5 years out. The IRTF is concerned with engaging with the researchers looking 5 to 10 years out and picking the best of the applied research and trying to bring those people into the standards community in the long term, to try and ensure the long-term health of the standards community, the long-term evolution of the internet. Excuse me. So we have these two organizations, the IETF and the IRTF. The IRTF is organized as a small-ish set of long-lived, broadly oriented research groups. There's currently, I think, 14 research groups. Each one covers quite a broad spectrum of technologies. And these groups tend to live for 5 to 10 years, and they're looking several years out. They're looking at things which are maybe suitable for standardization in some number of years, not something which is necessarily suitable for standardization now. The IETF, in contrast, is a much larger organization. It's comprised of a much larger number of quite narrowly focused research working groups, often with a relatively short lifetime. mean, there are certainly IETF groups which live for many years, in some cases many decades, but a lot of these groups are quite focused on a very narrow problem, and they come together and they solve a specific problem, or they develop a specific protocol and disband after 2, 3, 4 years, and so on. As I say, there's a large number of working groups in the IETF. These groups are organized into a number of areas, thematically by the level of the protocol stack, moving from the applications levels down through the infrastructure levels, the operations, and so on, and cover the broad spectrum of internet technologies. The IETF and the IRTF are both organized activities of the Internet Architecture Board, which provides oversight and perhaps architectural direction. And all of these three organizations publish in the RFC series of documents, and the RFC series are the primary series of standards for the Internet, although the series also publishes non-standards documents from the IAB and from the IRTF. If we focus on the IETF for a while, it's organized as I say, as a set of working groups. There are approximately 130 working groups, and they're organized into 7 different areas. The general area is IETF administration and operations. The technical areas are focused on network operations and management. How one operates a network, how tools for helping manage networks. They're focused on applications and real-time services, developing protocols such as those we're using to run this Zoom call. They're focusing on transport protocols, security, routing, and at the lowest levels, the internet working layer itself. It's very much an open organization. It's very much a volunteer-driven organization. There's no direct membership fees. There's no application process. If you want to get involved in the IETF, you can go to the website. You can look up when the meetings are happening and join the mailing list. And anyone can participate. You just have to join and go to the meetings, join the teleconferences, join the lists. And as I say, the goal of the organization is to publish the RFCs, the internet standards. IETF has been running for a very long time. The organization is, I guess, 30-ish years old, 35, 40 years old in its current form, and has existed in perhaps slightly different forms for a while before that. It's developed a number of very well-known protocols and continues to develop a number of well-known protocols. It will perhaps not surprise you that the TCP/IP protocol stack was developed by the IETF and standardized by what became the IETF. And there are still working groups, for example, in the transport area, working on the TCP protocol and maintaining the TCP protocol. It will perhaps not surprise you that there is a working group in the internet area looking at maintaining and extending the IPv6 protocol. There's a group in the applications area looking at email standards. There's one in the routing area developing the BGP interdomain routing protocol, and so on. So all of the protocols that you perhaps learned about when you were an undergraduate doing a networking course that you use day to day, were developed and standardized by the IETF. It's still an active organization. It's still developing protocols which are in widespread use. More recently, for example, the TLS 1.3 security protocol was finished, I guess 2 or 3 years ago now, and is rapidly replacing the older versions of the transport layer security for the web and for other applications. The new version of HTTP3 is in development, running over the new quick transport protocol, which is aiming to replace TCP and to improve performance, reduce connection establishment latencies, and improve security. So you can expect a new version of HTTP to be published probably later this year. And there are standards such as the WebRTC standards, which the IETF jointly developed with the World Wide Web Consortium, which power applications, as I say, like this Zoom call that we're using today, and which grew out of the earlier work on the real-time transport protocol and the session initiation protocol and so on, which forms the basis of a lot of the mobile phone standards, which also the core protocols were IETF developed. So this is an organization which is still developing protocols, and I think that is still continuing today. And there's a number of things working their way through the standardization process, which I think are interesting right now. Some examples, and obviously there are many more. There is a media over quick group, MOQ, in the applications area, which is looking at using the newly developed quick protocol to try and improve video conferencing applications, video streaming applications, with a particular focus on live video ingest for news broadcasts and live sports events and so on. There's a large-scale media operations group in the operations area looking at generalizing and sharing the experience from operators such as Netflix, the BBC iPlayer in this country, and the other large-scale video streaming operators around the world, and looking to leverage their experience, share expertise there, but also lead that into, bring that in and use that as requirements for the next generation of video streaming standards. There are groups like 6low and Suit, which are looking at Internet of Things devices, and 6low is looking at very low power IoT devices. Suit is looking at large-scale software update for Internet of Things devices. So trying to make the IoT devices which are increasingly in people's homes and in industrial automation and sensing applications, trying to make those more manageable, more updatable, lower power, lower resource consumption. There are people looking at applications like the MASC and the OHI groups, which are various privacy-preserving technologies. The OHI, if you have an iPhone or a Mac, you may have come across the private relay service that Apple introduced recently. These are standardizing that sort of technique to improve privacy. And then there's groups like the deterministic networking group, the network slicing group, the service function chaining group, which are looking at making the networks more predictable. They're looking at ways of slicing the network to give dedicated, more predictable services, and looking at managing functions and in-network services, and making those more manageable and more interoperable. And this is just a very quick flavor of what's going on. I think there's a pretty big range of activities here. As I say, there's about 130 working groups, so there's a lot of activities, both on very well-established protocols, but also on newer protocols, which are just starting to see uptake. So that sort of briefly explains what is the IETF? How might you get involved? Well, I think if you wish to get involved in these standards, you should first identify a problem. Try and figure out something that, problem you have that might be relevant to the internet standards community, something where the standards, changing the standards can help. And obviously not everything to do with the internet is related to the standards, and not every internet related problem can be solved by updating the standards. But certainly a number of them can. Having identified the problem, you would check if the IETF is interested in the work. You would then bring the work to an IETF group, try and develop your ideas. There'll be a review process, and eventually an updated RFC and an updated internet standard would be published. And this is actually a surprisingly achievable process, but it's one that you need to manage the way you go about doing it. It's one where if you want to get involved, you need to understand a little about how the IETF operates. The first thing I would say is don't start too early. Right? The IETF is not a research organization. It's not a place where you would do research. You may have a problem with the standards. You may want to extend or improve the standard protocols. You may have run into some limitations of the standardized protocols. And that's great, but try and understand what the problem is. Try and at least begin to identify a solution. If you're proposing something new, build at least a prototype to demonstrate that it has some potential of working. And try and get a well-understood scope and a well-understood problem, and then bring it to the standards community to try and demonstrate that you've done your homework, you know what needs to be done, and you're there to do the engineering to address the problem, to solve the problem. Once you've done that, have a look at this document, the Tao of IETF, which is a great newcomer's guide to the organization. And understand, of course, that the IETF, like any other large, long-lived organization, has its own culture, its own processes, and do at least a little bit of reading up on how the organization works. Right? And I'm not saying you should become an expert. Of course, as someone coming new to the organization, you will not be an expert. But having at least some idea of how the organization works will put you in good stead. And think about how the problem you're trying to address fits into the community. And quite often, people will come to the IETF, want to extend something that fits in the charter of an existing group. I think an example, perhaps relevant to your community, is that I guess in the early 2000s, there was some significant concern about TCP performance for high-speed, long-distance networks and for transferring large amounts of data over fast, long-distance connections. And people primarily from the high-energy physics community came to the IETF with this problem and worked with the TCP working group to understand the problem and to understand what was limiting TCP performance for these applications, and work to improve the performance there. And I think that's a pretty common approach, is that there's an existing working group in the area, and you want to extend or update or improve one of the protocols that group is doing. And you would do that by approaching the working group chairs and explaining what you're interested in doing, and they would then guide you through the process. And I think this is one of the areas where the openness of the IETF helps. It's very easy to join the working group mailing list, to look at the meeting recordings, to join the online meetings, perhaps even go to the in-person meeting, read the work in progress documents, see what the different working groups are doing, and see if the work if the work you're interested in, or if the protocol that you're looking to extend or improve has an existing group, and if what you're interested in doing fits within the scope of that group. It may not, of course. It's possible that you want to standardize a new protocol, or you want to develop a new set of extensions or techniques that don't necessarily fit within the scope of any of the existing groups. In which case you talk to the relevant area director, and they will either help you start a new group, or perhaps direct you to one of the area groups which have a broader remit and can look at how to handle new work and find the right home for new work. It's also possible, of course, that the IETF is not the right standards development organization for you. Perhaps you should be working with the Web Consortium or with one of the organizations developing lower layer link-led standards, for example. Or maybe your idea is perhaps still in the realm of research, and you should be talking to the IETF for network-related research. Once you have identified a group, you can bring your ideas to the IETF. And the IETF process in general is very much an iterative multi-stage review process. IETF is very much a bottom-up consensus-driven organization. It doesn't operate from a top-down vision for how the internet should work. It operates in a very bottom-up process. People bring ideas to the working groups, and they iteratively develop those ideas, and they bubble up through the process until they're produced as standards. And as perhaps is clear from using the network, there's not really a coherent grand plan for how the network should evolve. It's done by people scratching an itch, essentially, and developing technologies and standards that meet their needs. The development process is, as I say, it's a consensus-driven process. The people developing the standards bring a document to the community, and it's iteratively reviewed and developed until you get something where there is rough consensus that the resulting document is good and is appropriate to standardize, and generally some running code to demonstrate that it works. And the process looks a lot like any other working meeting or academic conference, with perhaps longer lines of microphones and more discussion, and more discussion rather than entirely a focus on presentations. It's a consensus process, and consensus processes can be slow. Documents often go through multiple rounds of revision, and the example on the slide here shows the timeline for a particular document, which was extending TCP for video to better support rate-limited traffic, such as video streaming. And you see from the timeline here, it took several years to go through the process, and there were, in this case, maybe 13, 14 revisions of the document. And I think this characteristic, right? It's an iterative, consensus-driven review process, and the ideas tend to evolve significantly as they go through the process. What works in a lab in a particular case tends not to work in general when deployed on the broader internet, and protocols often evolve significantly to make sure they work in all the corner cases that apply on the broader network. And as I say, it's not necessarily a fast process. The standards typically take around 3 years, maybe a dozen revisions before they get through the process. The charts on the slide, the one on the left, is measuring the number of days between the initial draft and the publication of the standard over the last 20 years or so. The one on the right is showing the number of revisions the documents go through. And we see that things are getting a little slower over time, and it's taking typically around 3 years to get the standards through the process currently. I think this is perhaps not surprising, right? That the network is clearly getting more complex. The internet is getting more pervasive. There are more, a bigger deployed base, more existing protocols. So there are more interdependencies, more of a deployed base which you have to work around and make sure you don't, new extensions work with the existing network. And so clearly it's going to take longer over time. One thing I do want to highlight, though, is that successful protocols are generally deployed as they're being developed. this is not, when I say it takes 3 years to publish a standard, this doesn't mean you work in the IETF for 3 years and then a document is published and then people start implementing, and then a few more years down the line, implementations and products start appearing. Protocols typically, if they're going to get deployed, if there's going to be interest in them, people start implementing quite early in this process, and there are products out there and in use before the final standard is published. And I think that process is actually quite desirable because it means you're getting implementation experience in to improve the standard. And quite often the final standard is rubber stamped and approving what's already widely deployed. And eventually, after this process, an RFC is published, and perhaps your idea is now an internet standard. Was it worth it? Well, I think that depends on your goal. If you're there to improve the network, if you're there to better understand the network, if you're there to get a new protocol out there, try and build some momentum to get a new protocol deployed, try to encourage some implementations of that protocol. If you're there to make contacts with industry, I think it's absolutely worthwhile. And I think as an operator or as a researcher, you can actually make a significant difference to the standards process and get new ideas adopted. And I think that that's eminently achievable, and I think it's a great way of getting your ideas into use, and a great way of solving problems with the network. As a computer networking researcher, trying to get a publication I can cite, as a scientist trying to get a publication you can cite, this is not a useful activity. It's a great way of getting research impact, which is something some funding bodies greatly appreciate and which others completely ignore. But it's not a great way of getting citable research publications. So that's the process. Who does this? Who writes these standards? Your usual set of big tech companies, primarily Cisco, Huawei, and the like. And we see the orange line here showing the growth of Huawei, the Cisco in the blue, and a number of other organizations. There's a steady set from academia, though. About 15% of the authors of internet standards are from academic institutions. And if we look at those, there's perhaps some well-known institutions, obviously Columbia, MIT, INRIA, UCL, and so on. But there's also some less well-known institutions involved. And I think what I want to get across is that small, determined research groups can actually have a pretty strong, outsized impact on the standards process. And if we look at this plot showing the number of internet standards published by coming out of different academic organizations, obviously at the top we see Columbia University, which is a very well-known organization. But this is perhaps one of the few university league tables where my own institution, the University of Glasgow, comes directly above MIT and Harvard. And so I think it's nice that relatively small groups can actually have, as I say, some significant impact in these standards. It's a process which rewards participants that commit to long-term engagements, and operators and academic research groups can have quite an outsized influence. All right, so that was the IETF. In the second part, I want to just quickly talk about some of the things that are coming down the line for the research community, and things which might affect the way these standards develop in the future. In particular, I want to talk about some of the work going on in the Internet Research Task Force, which, as I say, is an organization which tries to provide a link between the research community on one hand and the academic publishing community and the standards community in the IETF, and try and provide a forum for these two communities to meet. IETF is organized as a set of longer-term research groups and discussion forums where the researchers can talk with the standards makers in industry. And it's very much a venue where the researchers can learn from the engineers who are building and operating the network, and where the standards and operations community can learn from the researchers and where they can exchange ideas. It's organized as a set of research groups. We have them listed here, and I'll just talk through a few of them over the next few slides. So what's the IETF doing? What might be coming down in the research community that might affect the future of the network? Well, one area is a set of groups relating to security and privacy and human rights. There's a group, the Crypto Forum group, there's the CFRG here, which is developing low-level cryptographic primitives, many of which get wide adoption. Some of the standardized versions of the elliptic curves, the Cha-Cha symmetric encryption algorithm, came out of this group, and there's a bunch of work on PAKE algorithms and hybrid public key encryption and post-quantum encryption starting in this group now. So developing low-level cryptographic primitives. There's a research group looking at privacy-enhancing technologies and excuse me, onion routing and identity hiding tokens for access and things like that. And similarly, a group looking at human rights and the impact of human rights on the network, and trying to bring in those with internet governance experience, those from the human rights community, various NGOs, and try and understand the implications of the protocols for privacy and security and on broader human rights, such as freedom of speech, freedom of expression, and so on. So there's quite a nice interplay of research between low-level cryptographic primitives, broader privacy-preserving, privacy-enhancing technologies, and the human rights implications and legal and societal implications of these techniques. There are research groups looking at alternative architectures which are perhaps content or programmable, or content aware or more programmable. And these are areas which may perhaps be of interest to some in this community. They're looking at, can we or should we restructure the network around data and computation rather than around hosts? So the current internet architecture is very much structured around IP addresses, and IP addresses identify interfaces on particular hosts. And it's all focused on making connections to a particular device from which you then request data or services. And these research groups, the ICNRG and the Computation in the Network group, are focused on flipping that around and looking at what would happen if you structure the network based around named data items or based around named services which can be invoked. So they're looking about getting rid of IP addresses and thinking about how a network can restructure so you identify the data you're requesting or the service you're requesting. Focusing much more on pervasive caching, pervasive in-network computation, and what it means to do internetworking when the key primitives are big data or large-scale computation. And how can we restructure a network around that? And there's, I can dig out a talk if anyone's interested. There was a talk at the IETF last week looking at applying some of these ideas to the high energy physics community in the US for some of they were prototyping some ideas there, or applying it to large scale genomics data. I think there's potentially some interesting ideas for how the network might evolve in the very long term, and for in the shorter term, how content distribution networks and large-scale data overlays might develop. There are groups looking at path awareness, trying to see if we can benefit the applications by giving them more awareness of the internet path over which they are operating, and if we can benefit the network by giving it more awareness of the applications running over it. And the potential benefit here is that you can improve the performance of the applications. The applications can more rapidly adapt to the services and the capacity of the network. And the applications can request in-network support, in-network services, and could be more easily directed onto particular paths or particular routes through the network, or to invoke particular in-network caching or computation or other services. So I think there's potentially some nice ideas there. There are also some interesting questions around trust and privacy and network neutrality, because this is opening another avenue for control over network traffic. And it's giving perhaps operators more power, as well as giving the endpoints the ability to talk more to the network and request new features. So it's changing the balance of control as well as providing new features and new performance. So it changes the way the network operates in interesting ways. There is a research group looking at quantum internetworking and how it might be possible to establish and control interdomain paths, which can then distribute entangled quantum state. And in the simplest case, this is doing quantum key distribution for security protocols. Mostly, though, it's looking at the control plane to enable distributed quantum computers. And how can you set up the appropriate network paths such that entangled quantum state can be set up over the network in an interoperable way to enable quantum computers as they become available to quantum computations to work in a distributed manner. And that's being driven by a group in Delft, the University of Delft and QTech, and from KO University, trying to figure out how to make interoperable distributed quantum computers. And perhaps more down to earth, that there's a group looking at global access, sustainability, how to address the digital divide, and how to share expertise and raise awareness of network operations in perhaps parts of the world which are not so widely developed in terms of internet infrastructure. And a lot of this is looking at the challenges of networking in, for example, Africa or parts of India and so on, where the infrastructure is less well developed, and looking at how to address the perhaps unique infrastructure challenges those parts of the world have. But other parts are looking at some of the more rural and remote parts of the developed world and sharing experience in building infrastructure in those regions which are not well served by the utilities. Northern Canada, Scandinavia, even parts of the sort of west coast of Scotland and some of the islands, for example, and trying to share expertise in community networks between those people. And there's perhaps a much broader set of groups. I don't have time to talk about all these in detail. Perhaps the ones that may be of interest to this community, that there are a new congestion control algorithms being developed to improve data transfer performance. There are network coding algorithms, again, to improve performance and robustness. There are research groups looking at measuring and understanding performance, large-scale network operations and management, and so on. Let's say the goal is very much to foster collaborations, foster interactions between industry and the research communities. And that essentially is where I want to finish. I started by saying why you might care about protocol standards. I think you should care for two reasons. You should care because the network is not finished. You should care because the standards are evolving and might affect what you do on the network, especially if you're running large-scale systems. You should care because there are some quite speculative research ideas, which are perhaps a few years out, maybe 5 to 10 years out, but they potentially enable some significant new capabilities. I think in particular, some of the ideas in the relating to restructuring the network around data and computation have the potential to quite radically change the way the network operates and to have quite a large impact on organizations working with big data and large amounts of computation and caching and distributed systems. And I think it's useful to perhaps be aware of that and perhaps to be able to track that work. And I want to try and highlight the fact that the standards process is perhaps more open than you think. And if you are having problems with the standards and with the way the internet is developed and the limitations of the protocol standards, the IETF is actually a pretty open organization, and it's more feasible than you think as a relatively small research group or as an individual from a science community, rather than from a big tech company, to come in and actually change and influence those standards. So that's all I have to say. I hope some of that was interesting. I thank you for your time, and I'd be happy to take any questions.
Many thanks, Colin. Indeed, very interesting. And now I can see one raised hand from Caio Costa. So please go ahead.
Hi, Colin. Thank you very much for the talk. Very interesting. I have a question. I'm just asking for a friend here, okay? What advice do you have for someone who does not have professional experience with standards and who's not an academic, but would really like to move into that field? So you talked about the low barrier to entry to the IETF, but would that be the best way to start getting involved? Should one go back to school?
I think if you have experience in operating networks, if this person has experience in operating networks, I think that would, or experience of open source protocol development or something like that. Then I think joining some of the IETF groups, going to see what happens, I think would be. I think they would find that their experience is actually quite relevant. And obviously they would need to find the right groups, and it's quite a big organization, and it's perhaps quite easy to get lost. But certainly, there are people who come from the operations communities, from the open source communities, who make effective contributions reasonably quickly. And the IETF has the advantage over perhaps some of the other standards organizations in that it's aggressively open. So it's possible to join in and watch what's happening and attend the meetings at very, very little cost. I mean, obviously, if you're going to an in-person meeting, then you have to get on a plane and fly to wherever it is and pay the registration fee. But everything is online, and all the meetings are streamed, so it's easy to see what's happening and see if that person thinks they can make a contribution.
But again, well, thank you. But I'm asking more from the perspective of someone who doesn't. Who is from an operations background, but who doesn't really have much direct experience with that kind of work. Like, how could they start getting involved with that? Not asking necessarily getting involved with the standards bodies, although that might be an ultimate goal, but how to get started in that kind of work.
In the standards work or in the operations work?
Standards, yeah.
Standards work.
Sorry, I hope my question is clear. It's a bit confusing.
Yeah, I think so. I mean, start by finding, if that person wanted to get involved in the IETF, for example, they would start by finding the operations groups closest to their area. So if they were, they might look at some of the routing operations groups, or the network management groups, or the media streaming operations group if they were in video streaming world, or whatever the relevant area is, right? The DNS operations or whatever. They join the mailing list. They'd look at some of the documents which were being discussed. They'd sneak in the back of the online meetings and just listen and see what was happening, and have opinions. And if that person had opinions which were sort of, because they've been operating a network, they would know how things actually work, and they can say, well, that doesn't match how I see things working, or that doesn't address the sort of problems I'm currently seeing, or have you thought about this? Mm-hmm. And drift in through having opinions, and I suspect if they have sensible opinions, that they will rapidly find themselves becoming involved.
I see. Okay, thank you very much, and thank you, Maria.
Thank you. So then I'm checking, and I don't see more questions. So I think it was very nice. In my opinion, I was not aware of the IETF, so it was very interesting to learn about that in this lecture, and also this quantum computing internet. Could you say a little bit more about this?
I could try. Yes. I have to say, as the IETF chair, this is one of the groups which I understand perhaps least, along with the cryptography group. Because I am very much not a quantum physicist. Most of what they talk about is, and maybe this makes more sense to people in this community, is how to establish the optically clear paths across the network, such that I think that they talk about entangled bell pairs. So they can actually distribute the entangled qubits down the fiber, such that they can then build up a distributed quantum computation.
Okay.
And what that computation would do is not something which I am familiar with, but the idea seems to be that quantum computers look like they are starting to be practical to at least a certain degree. And once they're practical, it seems useful to be able to interconnect them in a way which allows distributed computations. And the simplest case there, I think, is quantum key distribution. But I guess some of the quantum algorithms can usefully do distributed computations, if only to scale up the algorithm to some extent. And they're looking at primarily standardized signaling protocols, so classical protocols that can set up the appropriate optically clear paths over which the quantum state can be distributed, if that makes sense to you.
Yes. Well, many thanks. Very interesting indeed. Okay. So then, in fact, the timing is arriving. So thank you very much, Colin, again, for this nice lecture. Let you know to all of you that this will be, this is recorded, and also Colin will provide the slides, so it will be in the Indico webpage.
If there are any other questions, or if I can provide more background information or more detail, then please let me know, and I will send you pointers to a lot more detail.
Okay, perfect. Okay, so thank you very much, all of you, and also let you know that the next lecture will be on Friday. Okay, the one on Thursday was cancelled. Okay, so have a very nice day. Ciao, ciao.
Thank you.